Hello. Today we're going to tackle the following problem. What is the wavelength of the yellow sodium emission, which has a frequency of 5.09 times 10 to the 14th per second? The first thing that I want you guys to do when you start to answer these types of problems is underline the important components of it. So they're telling us they give us the frequency, which is 5.09 times 10 to the 14th per second. That is the numerical value they give us, but they're asking us to find the wavelength. We know from lecture that wavelength and frequency are related to one another by the following equation. The speed of light is equal to lambda, which is wavelength, multiplied by nu, which is our frequency. So right now they give us frequency, and they say frequency is equal to 5.09 times 10 to the 14th per second. Okay, so once we've identified the components that they've given us, we can use the following equation and we can manipulate it because we know what the speed of light constant is. We know c is equal to 3 times 10 to the 8th meters per second. So 3.00 times 10 to the 8th meters per second. Well, we know two of the three variables, so we can solve for the other one. We can then solve for our wavelength by dividing each side by frequency, divide each side by frequency. And we now have the new formula. Wavelength is equal to the speed of light divided by our frequency. Well, the next part that you have to do is just plug everything in. You put 3.00 times 10 to the 8th meters per second divided by our 5.09 times 10 to the 14th per seconds. So seconds and seconds will cancel out. And then we will be left with our answer, 5.89 times 10 to the minus 7th meters. You can also convert this to nanometers, which you'll constantly see what wavelength is commonly displayed as. And so if we move our decimal 2 places to the right, it will then become 589 nanometers.